you can see, I have some very nice pipes behind me. They're very elegant, I would say. And attached to them, there's a contraption that when you pull it up and let go, it compresses the air and makes the air vibrate up through the tube so that there is a node forming in the center and antinodes at the end. And the frequency of the vibration is based on the length of the tube. So if the tube is taller, you'll have a lower frequency.
When air is
which will
forced
make
into a
have
pipe,
different
it
sound.
causes the air inside to vibrate and produce a sound.
That's physics.
The pitch or frequency of that sound depends on the length of the pipe. In general, longer pipes produce lower frequencies or deeper sounds, while shorter pipes produce higher frequencies or higher pitched sounds. This happens because sound waves move in waves and only in certain wavelengths that can fit inside of a pipe in ways that create standing waves, which are stable patterns where the wave reflects back and forth and reinforces itself. If a pipe is opened at one end and closed at the other, like in this case, the way that the sound wave fits inside is different than if both ends were open. At the closed end, the air can't move, so it forms a node, which is a point of no motion. And at the opened end, the air vibrates freely, forming an antinode, a point of maximum motion. The simplest wave that can fit inside of this kind of pipe has a length that is 1/4 of the length of the full wave. This means the pipe supports a wave with a relatively long wavelength, which results in low frequency.
I'm currently at the Lawrence Hall of Science, and behind me is the ALS, or Advanced Light Source, owned by UC Berkeley, which is a particle accelerator, or a cyclotron, which uses alternating electric fields and magnetic fields to have the particle accelerate to very fast speeds around the building in a circle, and it's been used to generate 3D images down to...
A cyclotron is a type of particle accelerator that speeds up charged particles like protons or ions using electric and magnetic fields. The particles start at the center of the machine and spiral outwards as they gain energy. The key idea is that the magnetic fields cause the particles to move in a circular path, while the electric fields, which switch directions rapidly, give them a push each time they cross the gap between two metal plates shaped like the letter D. They're often called D plates. Every time the particle crosses the gap, it speeds up a little more, and then travels in a circular motion, which gets larger and larger. This process continues until the particle reaches the outer edge of the cyclotron, where it can be directed out of the machine and used for experiments, or for medical treatments even. They're often used for physics research, even cancer therapy.
So here we have a high pressure fan and a beach ball, and because of the difference in air pressure, it just seems to be floating here. So it shoots out a big column of air, and since the ball is blocking its area, the wind goes around the ball and creates an area around the ball with high speed and low pressure, which keeps the ball there because it's attracted to this low pressure area. Because of that, when we put my hand here, there's a high pressure area forming here, and it's pushing the ball backwards without me even touching
So
it.
here, when we see the fan
And if I
blowing
let go,
air
it'll go
over
back
to
to where
the
it was
beach ball,
before.
fastward
And
air,
pressure
moving air,
is
is creating a low pressure zone around the ball that's like surrounding it, and the slower moving air that's around that is high pressure, which is holding the ball in place basically. And if the ball starts to drift to one side, the air starts to move faster around that side, which lowers the pressure in the center even more. And this high pressure region where the ball is moving to starts to like nudge the ball back to the center. And it's kind of like constantly being balanced from all the pressure being acted on it by every different side. It's like always being nudged back into the airstream because it's lower pressure there. It's kind of like what happens in sci-fi movies when there are people on a spaceship and they open the door to space, this vacuum, and people get sucked out into the nothingness.